In this video, we will be talking about reactions in aqueous solutions. So, first we're going to talk about polarity. We're going to get into deeper about this a little bit later, but essentially, a polar molecule is asymmetrical, and there are generally loose electrons, and those allow the polar molecules to form intermolecular forces, or IMFs. Usually, water is a very good example of this. Nonpolar molecules are symmetrical in their diagrams, and usually examples of that are hydrocarbons. On the right here, there's a picture of water and oil being combined. Water is polar and oil is nonpolar, and there's the saying like attracts like, which means that many polar molecules will dissolve with polar molecules, although mixing a polar and nonpolar substance will not make it dissolve. A solution is a homogeneous mixture. Essentially, a solute is dissolved in a solvent. The universal solvent is water. That's what you'll probably use in all of your labs. It's the universal solvent due to its polarity. So, in this case, this is table salt being mixed into water, and that's a solution because it is a homogeneous mixture where the salt is equally distributed with the water. So this is a solution, and this is not a solution. So, properties of aqueous solutions. If you have a strong acid, base, or a very soluble salt, they will completely dissociate and conduct electricity, as seen here. But it conducts electricity because the ions are freely floating around. In this resembles possibly table salt, where you have the sodium ions and the chloride ions. And they will not form a solid in water because it's an ionic compound and it'll easily split up in the water. So, the weak acid base or insoluble salt does not completely dissociate and does not conduct electricity because there are not as much ionic compounds for it to form together. This is not necessarily table salt, but just an image of how a salt might not necessarily dissociate completely in water. So molarity you use a lot in chemistry, especially in stoichiometry problems in a laboratory setting. So molarity is equal to moles of solute over liters of solution. Do not forget to convert to liters if given milliliters. Oftentimes problems will give you milliliters. So molarity measures how concentrated a solution is. And I'll link a problem down here for you to go see how molarity works with numbers. So for dilution, you usually don't use this in problems, but definitely in labs you use this a lot. It would be M1V1 equals M2V2. So if you're looking for a solution that has a given molarity and you're given a more concentrated solution or a more diluted solution, this formula will determine how much volume of the other solution to add or mix with water to give you the given molarity that you want. So you can dilute the solution with water universally because it's a universal solvent. So also attached here will be another example problem where you can learn about dilution. Thanks for watching.